Okay, in this lecture, we're going to look at some of the properties of water, which are important to understand why we have some substances that dissolve in water. The properties that we're going to look at is density, we're going to look at solution chemistry, solvents and solutes, and then also concentration units. So density is a topic that isn't covered extensively in our textbook, but I think it's an important topic for us to understand. It's something that you do encounter in your everyday life. Density is used to explain why ice floats, or why does one substance float on top of another substance. Density is a measure of how much matter is in a certain volume. So the measure of density is mass divided by volume. So for example, it would tell us how much does 1 gram of water, let me take a step back. How much does 1 milliliter of water weigh? That would be the density. The higher the density, the more likely it is to separate out from a substance. So for example, if we look at this picture here, we have a penny floating on some type of liquid. What we can say here is the density of the penny is less than the density of this liquid. If we look at this test tube, we have 3 different solvents, or 3 different compounds here. We can say that the one on the bottom is the most dense, followed by the blue, and then the one on the top is the least dense. And so if we think about something like oil floating on water, what we can say there is that oil is less dense than the water. The common units that we use for density for liquids, which is what we'll encounter the most in this class, is grams per milliliter. Gases are in grams per liter, and solids in grams per centimeter cubed. So let's look at a couple of examples of density calculations. This first one is asking about the oil of wintergreen, which is a colorless liquid that is used as a flavoring. It's saying a 28.1 gram sample of this oil takes up a volume of 23.7 milliliters. So what is the density of oil of wintergreen? So we have our mass, our 28.1 grams, our volume, our 23.7 grams. Remember, density is mass divided by volume. So in this case, our density is our 28.1 grams divided by the 23.7 milliliters. And that density works out to be 1.19 gram per milliliter. You can also predict a volume some substance will take up based on its density and the amount that you have. So here's an example with gasoline, which has a density of 0.718 gram per milliliter. So we want to know, what volume does 454 grams of gasoline take up? So remember, our density is our mass per volume. In this problem, we have mass and we have density. So we have our mass, we have our density, we can calculate volume. If we work out this calculation, it's telling us that 454 grams of gasoline would take up a volume of 632 milliliters. Density is something that we will look at with water. Again, as we said, the density explains why oil will float on top of water, and this is something we'll look at in class. Okay, so what I want to move on to now is looking at water as a solvent. So pure water doesn't exist on Earth. There is stuff always going to be dissolved in our water. And water has the ability to dissolve a lot of different substances. This is good in the sense that we can dissolve stuff in water, such as salt or sugar. We can dissolve something like Kool-Aid in water to make a drink. It's also bad in the sense of, if you put a solid contaminant into the environment, there's a good chance that some of that will dissolve into the water and can contaminate our drinking water sources. Anything that is dissolved in water is considered an impurity, even if it's toxic or not. When we talk about water quality, we are looking at what is dissolved and how much is dissolved in water. So you might have a very small concentration of a substance dissolved in water, so that's the how much, and therefore the water is not toxic, but if you increase the amount, it can become toxic. So we need to understand why certain substances dissolve in water easily. And that's based on the solubility. You can look up a table of solubilities and it will tell you how much of a substance will dissolve in water. When we talk about something dissolving in water, we are talking about a solution. A solution is a homogeneous mixture of uniform composition. A solution is composed of a solvent and solutes. The solvent is a substance capable of dissolving other substances. This is usually present in the greater amount. So a lot of what we will talk about in this class, our solvent is water. The solute is a substance that dissolves in the solvent, and usually it's in a lesser amount. So our solute will be what substances are dissolved in water. When we're talking about water as a solvent, we call these types of solutions aqueous solutions. So aqueous solutions are solutions that have water as a solvent. And what we also often want to look at is the concentration of a solute in a solution. So the concentration is a way that we express the ratio of the amount of solute to solvent. So a couple different ways that we can express concentration: parts per hundred, which is a percent, parts per million, and parts per billion. So if we first look at percent, or parts per hundred, if we have a solution in which 20 grams of sodium chloride is dissolved in 80 grams of water, your total mass of your solution is 100 grams. And therefore, this is a 20% solution of sodium chloride. So 20 divided by 100 grams, that times 100 to get our percent. Part per million, this is the same as saying 1 gram of solute in 1 million grams of water. If we do some conversions, this is the equivalent of 1 milligram of solute in water. Another common unit that we use is parts per billion. So if something is 2 parts per billion mercury, this is the same as saying 2 grams of mercury dissolved in 1 billion grams of water, which is equivalent to 2 micrograms of mercury in 1 liter of water. A very common concentration term that we use is molarity. This is because molarity is based on the moles of solute per liter. And you should realize up at this point that we deal with moles a lot in chemistry when we're dealing with chemical reactions. Moles is a very useful term to use. It's often more useful than grams. So when we're dealing with molarity, we're dealing moles of solute per liter. Brackets are used to express molarity. So if we have 1.0 moles sodium chloride, we can express this with a bracket. This is saying the molarity of sodium chloride is equal to 1.0 molar. Molar is our moles per liter. When you add sodium chloride to water, this will dissociate into ions, and we'll talk about this in the next recorded lecture. So you also have 1 mole of sodium and 1 mole of chloride when this dissolves in water. If you were to make a 1 molar solution of sodium chloride, you would take 58.5 grams. That is equivalent to 1 mole. You would add that to the bottom of your container, in this case a flask. You would add some water, dissolve it up, and then fill up that water to the 1 liter mark. Notice we're not adding 58.5 grams to 1 liter. That the volume of your solution is the volume of your solute and your solvent combined. So it's the volume taken up by both the sodium chloride and the water. So we want to add that solid for it first, dissolve it up, because that solid will take up some volume.